Okay, let's look at empirical models. Um, uh, Before I go into the go through the contents, let me address the idea here, right? So, what is actually we are looking at in empirical models, and what is the purpose of this, the whole concept, right? So, let's say I have a graph which is generated with some data. So for example, let's say this is x and this is y, and I have some data here which is x, let's say 1, 2 and 3. I have 3 values for x, and I have some values for the y. Maybe this is 1 and this is 2.2, this is 3 point some other value like 5, something like that, right? So yeah, that means exactly I get somewhere here a value, and for this don't get 2, I get something little bit beyond 2 or somewhere here, right? And again, let's say 4, I have 4 again, and for 3 I have 3.5, which is 3 is here, halfway is somewhere up here, right? Okay, and then for the 4, so the 4 is here and the 4 is here, so it is like this. So this is actually when you want to look at it, it's just like one straight line, right? But the thing here is, even it's a one straight line, I can see some it is not actually matching or following these numbers exactly the way it should be. If it is a perfect the graph, obviously you're supposed to get 1 here, 2 here, 3 and 4 here. That will be, I can guess this, so this will be a one line, right? So but it is not the case in here. I can draw which is something like this, or I can draw another which is to fit this one like this, right? Or I can draw something like this. So anyway, to match these points, I can draw some lines. So this is not actually accurate, but you get the idea, right? So I can draw some lines which is the varying because of these values right here, right? But ideal graph has to be look like, obviously, 1 to 1, 2 to 2, 3 to 3. So in that case I can call this a perfect line. But when you're looking at this data, you can assume this line might be like this, right? Okay, right? So but unfortunately you don't get the accurate data. Because of that, this line vary, right? So what is the perfect line in this kind of a data set, that if you have, which line is the right line, or most approximately corrected line, or the closer line that you can decide this graph about, right? So that is the idea, and that is the challenge you're facing here, and how we're going to solve this is the one that we're going to look at, right? So the idea is what? So yeah, when you're collecting the data for some the contents that you are working on, or if you have some collecting some statistics, these statistics may be falling not exactly as you expected, so it can be something like this, right? But if I want to draw a graph for this, I cannot go like this, right? It's not going to work like that, right? So in that case, I should have an idea how this graph should be look like, right? So in this case, well, instead of I'm going like this, I approximate this data, right? So I have something like this. If I have something vary like that, I might get one line which is fit all these together. Either this, either this, something like that. One of those lines will fit into all of this more closer, right? So that is the approximation, and this is what you're going to look at, whether which line it has to be in this kind of a data set, which is not giving you accurate data as well. I mean, as you expected, it might be vary like that. So in that case, how do I really going to find exact line, right? Exact graph shape. So when I'm talking about this, well, there are some concepts here. One is called empirical model. So this is what we call empirical model. Empirical model consists of a function that fits the data. So we are looking at actually fitting data, the graph that's actually fitting the data, right? So that's what the idea, right? So yeah, here's the definition of that. So make sure you understand the definition. So if you take the linear empirical model, for example, so right here we have one. So these are the data that I have, which is nothing but x is 0.2, and then y get 0.1, x is 0.3, then the y get x is 0.4, and the y get 0.3. So 4 and 3, and again I have x is 3 and 3, so it's 3 and 3 right here, and then again you have 3 and 6, so it's something like 3 and 6. So these are the lines. So in that case I should these are the points. In that case I should have one line which is fit all these data, and then you assume, okay, this is a linear connection between x and y, and it should be something closer to this. So how do I really going to manage that and figure out which one is the right line for this? Okay, so I believe you already know the line equation, right? So the line equation, if I draw a line on this, the line equation will be whatever the line I get for this will be equal to nothing but y equals, right, mx plus b. So that is the equation of the line. So any of these lines, this one, whatever the line I draw here, all falling into the same equation. Only thing that you have to worry about or consider in this case is this m and this b right here. Okay, so these are the two things will change this line from this line, from this line, from this line to this line, whatever the line you take, depending on these two values. So I had to calculate these two values. That is the goal, right? So how do I calculate it, and what makes it make sense when you collecting these kind of a data which is not really accurate, but I'm assuming it will be falling into one line of equations, right? Maybe there's a faulty reading, so in that case, yeah, maybe your line is a little bit different than what you expected. But how do you really going to manage this? So the problem is, yeah, we have different data, and the solution is, okay, it should fit into one kind of a graph. So how do I find the graph? So that is what empirical models teaches you. Okay, right, so let's move on. So yeah, so this is the example of a linear empirical model. So the linear empirical model explain in the line fits the data, and we call it a linear of the line combination. So the linear combination, right? So if you call n is a positive integer, and the linear combination of x1, x2, x3, you can define it in this form. If you remember the polynomial function we were talking about earlier in the last lecture, that is something similar to this, and this a1, a2 and a3 are the constant values that give you an idea of what is this graph is all about, right? When it comes to the polynomials, again, if you cannot remember, you can go and look at the previous lecture. So if you have a function like this, right, 4 minus 3x plus 19 squared, in this case you can see these are the linear combination, and these are the constant values, right? So you can separate this equation into those two. The constants are the ones which is a1, a2, a3 and a4. So if I write this in another form, which is applying a1, a2, a3 and a4, how does it look like? So my equation is here saying 4 minus 3x plus 19x squared. So when you take this equation, right, what is my a1 is equal to, what is my a0 is equal to, what is my a2 is equal to, right? You can see x0 is equals 1, x to the power 0 is equal 1, right? So there's, here you have x to the power 0, and this is x to the power 1, this is x to the power 2. So in this case, this guy is the one which you consider as a0, right? And this one is the one you consider as a1, and then this is the one which is you call a19, right? So x squared is this one, so the a2, right? So this is a combination of these can draw a graph. Actually, if you have something look like this, it might be going somewhere like either it is going something like this or something like this, whatever, depends, right? Either can be a curve like that. So anyway, so so that is what this means actually. So you can calculate this, obviously, if you put a value for x, and you can calculate the y, right? How do you do that? Well, if I have something like x, and then I can calculate y value. How do you calculate that? Well, my x, I can say x is 0. If the x is 0, 1, 2, 3, 4. So when the x is 0, these two will be 0. In that case, it's 4, right? When x is 1, that's a 16 plus 4 is 20, right? And when x is 2, it will be a huge value. So it is exponentially growing, it seems like. So it's starting from so if I get an idea on this, this is a graph which is starting from 4, right, and then it's going exponentially like this. So that is the graph might be look like. Okay, so that is the idea I get by just these values. Right, so it's a combination of 3 points like this, right? So that's what it means, a linear combination. All right, I mean, actually this is a quadratic equation, but you can define these as a linear combination of these factors, right? Okay, so that's what it's explaining here. All right, so let's move on. Okay, so how do I really going to get a linear regression? So what does linear regression means? Well, linear regression is how do I predict something which is fit into right the graph, right? So what line is fits into all these dots that I'm going to get? What I mean is the same thing I'm repeating in this lecture. I was talking about it in the previous, at the beginning of the lecture as well, which means I have some data set, right? And I want to get the right line that covers most of it. So that is the linear regression. In order to get that, the best fit on this whole graph is you get this distance, right? Here, here, and here. You calculate those distances and you get the minimum of all these. If you get the minimum distance here, right? So that means that will be the best fit for the line. So that's what the idea here. That's what we're going to generate. Okay, so we know in a linear function we define it by, the linear equation we define it by y equals mx plus b, right? And usually when you're drawing a graph for this, you give values to the x and you calculate the y. So in that case, the predictor variable is always x and response variable is y, right? So this is what we do when you want to draw a graph, right? I predict means I give some values to this guy, and the response is when you apply these to this value, you get the y value, whatever the value you get, right? So that is what the predictor and the response means, right? Okay, so the linear least square regression means actually you get the square values of this distance. Let me get a better pointer. So what I'm actually, the idea here is you take the vertical distance. Vertical distance means if I have something like this on my graph, I get these distances. Calculate these distances, right? All of it, and actually you get the sum of that by squaring these values and see which one is the least square sum that you get. So if you get a least square sum, we consider that one as the proper line. So for example, the vertical distance is the squares of vertical distances from the data point to the line. So what is that means is when you having a graph like this, what I have to do is calculate these distances, and square it and add all together and see which one fits better. Okay, so the least value of this. Right, so before I move to that step, I like to introduce you one concept or the way you're looking at this. So so that's what we're talking about here, right? So I know the predictor variable and I know what is the response variable, right? So how do I really know the vertical distance actually from a point to the line, right? So let's say, for example, this is the graph that I have, and this is the line that I'm expecting to have, y equals mx plus b, and these are the data I have already, right? So in this data means what? I already know those values, right? I know what is x, I know what is y here, right? And all these points I know because that's what given by the chart or my findings, right? But so how do I know the distance between these two? what is this distance, right? So that is an interesting question. So that is actually, distance means what? Vertical distance means the difference of y values, right? Because this is my y-axis. So it is a difference between two y values, right? Here also two y values, here also two y values. So it's a difference between 2 points or the two values of y, right? So how do I calculate that? Okay, so the first thing what we know is we know these points, right? So here it says, okay, I directly get one point here. So let's say this guy, yes, this guy is on my case here is 0.2, and then I get 0.1 here, right? So 0.1 and 0.2. So that's my equation. So the first thing is I want to find the distance from here to here, right? Okay. If I put this in an equation of a line, if I get this mx plus b, what this means is if I apply 0.2 to this one, right? So that means x, when x is equal to 0.2, what is y? Y will be equal to, so I put 0.2 here, right? 0.2 m plus b, right? So I replace what? I replace my x with that, right? So this is what x and y, if the line is already going on it, on the point, right? But in my case, it's not the case. I have one point here, right? But my line is going from here to here, right? So there's a difference, but it's already giving me the y value, actually, the corresponding y value, right? So the difference between this point to this point is what? This point, I already know my the line point here, right? So that is the line point. That means when my x is 0.2, my line point right here should be this, right? But actually what I got from my inputs is this, right? So difference between from here to here is nothing but the difference between this value minus this value, right? So that's the difference between here to here, right? Yeah. Okay. So this is what it's explaining here, right here. So if it is on this line, if my x is 0.2, then the y value will be m multiplied by 0.2 plus b, which is exactly this one. And it says, okay, so this is already given to you. In that case, the difference in the y values is nothing but I get that value, subtract this. That means I'm taking a difference between 2 points, right? Okay, so these values will vary or the change. Either some values might be negative values, some will be the positive values. Why? Well, if we have the point above the line, this will be positive, obviously. If you have the line the below the point, actually, if it is above, it will be negative. If you have it below, it will be positive, right? For example, if I take this one as a big value, right? This is the bigger value, and subtract 0.1, this is always a positive value. But in the other case, if I consider somewhere here a point which may be the greater, right, than this line. So if I do this minus like 4 or something, obviously this is less than. Why? Because the 4 is bigger than this one, right? So in that case, either it will be negative or positive. So you don't take the absolute value in this case. What you do is you get the square of this value, square of it, right? The square of it, and add all the squares together and find what is the minimum sum. So that will help you to figure out what is the actual vertical distance, the square of vertical the distance. So this is the thing that we call the linear regression. Okay, so this is what we call linear regression. Right, so that helps to plot or to fit the graph properly, right? So this is the example of it. So the linear regression is nothing but what is your goal is finding your m and b, right? So that the sum of the squares of the vertical distance is the smallest as possible. So let me repeat what I'm talking about here. If you just missed or your mind was not there, obviously now you can repeat your record and look at it again. But anyway, so what I'm saying here is just to recall again, so you can, once while I'm repeating, at least you will hit that in your mind sometime, right? So what it says here, it says regression is find m and b. M and b means I will get a one line here, and I call this line y equals mx plus b. I don't know what is this. I don't know what is this. Right? Other data I have. How do you find these two? I find a line which is that gives me the sum of the squares of the vertical distance. So that means you take the vertical distance, right, and you square each of them. You square each of them. So this will be y1 value, y2 value, or whatever the distance, right? So you get this, let's say v0. This is v1. This is v2. This is v3. Let's take it like that. And what I'm asking here is, what this means is, you get v0 squared plus v1 squared plus v3 squared plus so 2 squared right here. So I get this value, and I'm checking the smallest value, right? If I can find the smallest value, so that will be the case, right? So how do you write this in terms of mathematics? Well, I can write it if I index these points. I can say one point is x1 y1, next point is x2 y2, xn yn is somewhere there, right? So all the points I can write it like this, right? And then well, the sum of those will be, this is the symbol that you're writing to be called sum of them, right? And since you have this one goes 1 2 3 4 5 6 to n, right? So I can say a counter here, I is going 1 to n, and well, what I had to calculate is nothing but the vertical distances, right? So I can say vi square, right, because I call these v's, right? So generalize v. What is this v is equal to? Well, that is nothing but when you apply your x value to this equation, right, and then subtract the y value of it, right? So subtract the y value means this guy right here, right? So what this means is, like the one that I was talking about just a minute ago, I show you how you get that equation. For the x value, it will be your m and your x, right? And if it is x1, it is x1 plus the b part, right? And then you subtract the y1 on this, right? Since it is a square, I'm getting a square. So this is equivalent to if I consider these as i's, right, because it's First one is 1, second one is 2, and so on from I1 to n. So I can just apply that here, and this is equivalent to this, right? Okay, I just replace this v by this value. Okay, so then you square it. So this is the expanded version of it. How do you write when you're having expanded version of it? So I just have in this with this equation that is equivalent to this distance plus this distance plus this distance plus this up to n. So that is what the calculation is. So if you understand up to this level, you pretty much know what is empirical model. So I think you good to go with it. So understand up to here is very important. Actually, that's all you have to understand in this the content up to the equation, right? Right. So this is the idea, and this is how we calculate it. Well, the one thing is, well, it's not easy to calculate these m and b by looking at this, right? So we have one way of doing that, okay? And so this is what I was talking about. So you can see the vertical distance of each point. So you can illustrate each point, and then you square it and add it together. And here, when it comes to calculations of that, we using a calculus, minimization techniques will be look like this. So how do you get these values? Well, using calculus you can do that, right? So that's what it says here, right? So this is what is equal to get the smallest sum of the vertical square of vertical distances. So this is what the m and b is given to you if you want to find that value, right? So what does this means, and how do I calculate this? So this is, pay attention on this. In your quiz, what I should give you, what I'm going to give you is some points like this. Let's say I have 0 and 1. Let's say I have 1 and 3. Let's say I have another one. Let's say another point, which is 2 and 4, maybe 2 and 2. Another one which is 3 and 4, right? Okay, so that's what we have. And I want to calculate m. How do I do this? So this is one of the questions can given to you, right? So what are these means? Let's say this part right here, right? So I have one here. So I have 4 points, right? The 4 points. So the n is 4. So I know n is 4. That is one thing I know. What else I know? Well, to calculate these values. So what is this means? Xi, yi. What is that equivalent to? Well, that would be equivalent to nothing but this. So x and I multiply. So it is 0 multiplied by 1. Right, that is the first term, plus 1 multiplied by 3. That's the second term, plus, and 2 multiplied by 2, third term, plus 3 multiplied by 4. So what is this means is this. So what you get here? All the 0 and 3 plus 4 is 7. 7 plus 12 is 19, right? I guess I'm right. Okay, yeah, probably 3 plus 4, yeah, plus 12. Okay, so that's what I get. Maybe I'm wrong. So yes, 7. Yeah, 7 plus 8. Yeah, that's right. I'm sorry. And the second term, right? This one, which I have xi, and then again yi. So what is that means? You add all the x's together. So it is 1, plus 1 plus 2 plus 3, and you multiply that by all the y's together. So it is 1 plus 3 plus 2 plus 4, right? So what is this equal to? Well, this one is 3 plus 5 is 6, multiplied by here you get 6 and 4, it is 10, right? So it is 10, so it will be equal to 60, right? So that's that, right? So what else I have? I have something xi squared and add all together. So here I'm squaring it and add 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So I get 5, 13 here. I mean 14 here, 14. And so this is what you do is, here is you get this guy and you add all together and square it. So in this case I get 0 plus 1 plus 2 plus 3, and then I'm squaring it, right? When you're squaring it, so I get here is 6, so I get 36. Yeah, 36. Right, so that is that. Okay, so I know all these values to calculate m now, right? So this is the bottom part and this is the top part, right? In the top part, this is 19, I know, and this is 60, I know that, and this is 14, and this is 36. So that's how you do when I ask you to do this in your exams as well. So this is times 4, this is times 4, right? Okay, so the final answer will be something whatever you calculate here, which is 19 times 4 is, I think it is 6 here, and 76, yeah, right, something like that. Yes, 76 minus 60 is the top part, right? And so this will give you nothing but 16 points, and the bottom is here is 6 and 56, right? Yeah, I think, yeah, that is 56 minus 36 is nothing but, I get 20, right? So what is this? M is equal to 16 divided by 20, which is, if you divide both sides by 4, I get something look like this. So that is my M value, right? So what is the B value here? So the B value will be, well, the bottom will be the same. So I know this part is 20. I know x squared is this one right here, which is 14, right? And so let me get a different color for this, so it will be easy for you to recognize, right? And I have 14 here. I already know that value. And y, add all the y's together and then multiply this. So what are all the y's is 10, I guess, right? Yeah, that is 10. And subtract, I already know this one is what? I know that is 19. So this is 19, right? You multiply that by adding all together of the x values, which is give you 6. Yeah, that's pretty much it. So what is b value is going to be? So it is 140, right, minus this is going to be 4 and yeah, so 6 times is 14, right? Yeah, so 114. Yes, yeah, it's probably that's right. So the difference between these two will be equal to, I mean, divide by 20. Right. So the difference between these two is nothing but 26. Right? Yeah. Is it? Is that right? Yeah. 26. 26 divided by 20. Right. Or you can call it. You can divide both sides by 2. That is what it is. Right. So this what is the equation in that case? So y equals 4 over 5 x plus 1.3. Yeah, so this is the equation of a line which is fits these points properly in your graph. Right. So this is the equation of this line. Right, so that's how you do it. So I would give you some points here and ask you to calculate. So obviously you don't have to remember this equation. Well, this is an open book anyway, so you can look at it anyway. So I don't have to give you this. It's already there and in your notes. You look at it, you calculate it, and then you come up with this equation. Right. So this means nothing but adding. Right. So this one says add first and then multiply. And this one says okay, square it first and then add. Here add it first and then square it. Right. So those are the different terms. When you're looking at it, you can understand it. Right. Okay, so I hope you understand this part. It's very important that you know you get this part. Right. Okay. Right. So right. And then looking at the nonlinear terms, like for example, what is nonlinear terms means? Well, something look like this. Maybe it is very close, but it's not really a straight line to fit this guys, right? So this will be a little bit curvy, right? So you know, if you have something with more than one term, right, like for example, yeah, I was talking about this earlier, right? This one, this kind of thing. Well, there's nothing after the x squared. So let's take something like this. For example, it's always giving you a curve, right? So if I get only the y positive, x positive, you get something look like this, right? If I have this. So that means if you have a power here, usually you get a little bit curvy looking graph. How do I know this is this? Well, you can just estimate that if you have x and y, 0, 1, 2, 3, that's what predictor, and the response will be what? X squared, that means 0, x squared of this is 1, x squared of 2 is 4, x squared of 3 is 9, like that, right? So that means, yeah, it's growing very fast, so it will be this shape right here, right? So that kind of a shape would fit this one. So how do I know exactly which one it is? Well, that is a trial and error. You just try and see whether it fits into those things. You can do that, right? And that is the experiment is showing you here. So I have some values, x and y, and so this is the line right here, and I want to fit all the values in there. So I take one of these values, like for example here I get x squared and y and plot that. If it is not good, I would say x cubed and y or x4 and y. So here they already showing you here, instead of x value itself, which is giving you this straight line or these points right here, I'm going to square these values. I'm going to square the x values. So if you have the x squared and then so it is 1.4 here. If I square this, it will fit into something called 2.2, right, or a little bit less than 2.2, right, like that. So here is the graph that I was squaring all these x values, right? Okay, so you can see this line is getting closer a little bit right here, and here is a cube. Well, the cube is not quite right, but it's very close right here. You can see that, right? And then we'll move to x4. So look at these two. X3 is going almost the upper half of the circle, and when it is come to x4, it is going the bottom part of this line. So that means what? This power of whatever the x to the power part, this part, exponent you call it, right? And it might be between 4 and 3, right? If I have finding something. So in this case, yeah, we just get a conclusion approximately this will be fit mostly if I have x to the power 3.5. That gives you a little idea exactly how this falling into this line. So the line fits, therefore the line fits on this equation. It says y equals, you take these values and then you get the power, you transform those points to the equation like this. So you get 3 to the power x point 3 and y. How do I get these values? Well, this is what actually I'm applying for my x and y onto this equation to find mn x. So if I use that for the mn x values by these equations, right? These equations up here, where is it? Sorry, it's just dancing, right? Okay, so if I get these values by applying those, instead of x, I'm going to have x to the power something, right? Then I get some equation look like actually something look like this. Okay, right, so that helps me to come up with this equation. So there's I mean actually I can, I mean these values mn, this one, and when you're writing the equation, obviously you have to write x to the power 3.5, not x, right? So this z, which right here obtains x to the power 3.5, and this is what m, this is what b. So I just calculated by using that equation, and I can say this is what the graph is look like. So this means, yeah, it fits mostly into those lines, right? So the actual graph is this right here. Okay, so there's nothing to calculate in it, so that's why I'm just talking about it. So this is what the graph is look like, and that's how we calculate it, right? And yeah, so you can get the range of it, the actual data range. If you really want to take 1.3 to 1.73, so this is 1.3, which is when you're looking at this one, you don't consider the negative values, so you can get some range from here to here. That's what they're talking about here. The 1.3 to 1.7, if you get a one range, that is what we call in the x value range, right? That we consider as actual data, right? Okay, so so that is what the solving for y in a one-term model. So that is also we're going to talk about the same thing, but in this case this curve is going to be a little bit upward, not downward, right? So it's going to be upward. So if it is upward, instead of x, I can have the powers of y as well, right? So if I have powers for the y, uh, so this is what they're talking about here. Instead of x, now I'm putting the y. So if I want to get this linear line like this, uh, I'm getting the exponent value of y instead of x, right? And then that fits mostly. Of course, I can apply that to my above equations and calculate the m and b. So in this case, you have to consider there are two things here. One is u and one is z. They just define those with that. And if you want to substitute the value, usually you don't write like write the equations look like this. For example, we already have something called the prediction value, which is always x, and the response value always y. So in this case, this is response, right? So this is response, and this is a predict value, right? Okay. So because of that, when you're writing these equations, you don't put the powers here, right? So the power parts, which is always coming to this guy, whatever the power plus b, right? So in this side, we don't do that. So in that case, for example, if I want to write x squared is equal mx plus b, the best way to write this is I say the y is equal to y squared equal mx plus b. If I want to get if I want to express this equation, I usually write it like mx plus b, it's the square root, right? Yeah. Or I can write it like mx plus b to the power half. So it is a reciprocal of whatever the value here I'm writing here. So 1 over that value, right? So that's what we usually writing. So in this case, I know this value, I know this value. So I can write this as actually, and notice my value is up there is, here is 5 over 6. It's a 5 over 6, right? So so in this case, if it is 5 over 6, you can see when it comes to the other side. So this is actually 5. 1 minute, please. Okay, don't need that big. So let's get a small one. So what I have here is actually 5 over 6 is equal this equation right here, right? And so it is 5.48629 plus 0.267869 to this whole thing, 2x, right? So that's what I have, right? Instead of like this, I'm just getting a reciprocal of this. So that means y will be equal to this whole thing right here with the x value, and this one top this and opposite of this. So that means 6 over 5, which is showing here, this equation, right? So that's how you write it. Okay, so this will perfectly match the equation, right? So so the graph will be actually look like this. So that is a y change instead of x change. So there's a one way of doing that. So you see if it is like that, you can apply powers to the y and see whether that fits, right? So now you can see the difference between these two. This one is concave downward, which is the curvy on this direction, right? So in that case, I have y squared. If I have direction changed a little to the other side, it's better you have the y powers. And then after you calculate your m and b, I can write my equation look like this. So that fits, right? Okay. All right. So one more thing I want to point out here is a multi-term model. So that means I have so weird looking one like this. Right. How do I actually plot this kind of thing? So what they're talking about here is, well, break it to pieces, right? Break it to pieces, small pieces like this. Okay, and then you calculate the same thing for each of these joints, and then your graph will be actually addition of all that at the end. So that's what it's talking about here. Well, so that's a process called interpolation of all these pieces. And yeah, I'm not trying to test you on this, but I like you to understand if there is something like the weird data that won't fit into one line or a one shape, how do I really going to come up with a function for that? So that is something that I like you to understand. So that is what this part is all about. Okay, so the multi-term model. Okay, right. So I think this is all I have to teach you on empirical models. So yeah, so this Friday quiz probably I will ask up to this. So make sure you study and yeah, go through the examples I show you. Definitely, that's what I'm going to ask you. Right? Okay. Right. I'll see you on another lecture.